We're going to continue on with where we left off in the first part of this video, which was the quenching method. We left off on this picture here, and again, as mentioned before, you're going to dip it and you're going to go trying to create a figure of 8 when you're dipping it, and try to, of course, submerge the whole thing. Okay. The next part is tempering. So what happens when you harden is that it's just the metals become really, really hard. And by making them that hard, you're actually making them more like glass where you can shatter it, right? It's brittle. So you have to, basically you create internal stress inside the metal, right? And that what makes it so that it's brittle. So now you won't be able to use it at this stage because you could crack it, it could break. As I mentioned in the first part, there's a really good video that we expect you guys to watch, an older video, and it shows all this process, hardening, tempering, annealing, and all that, and it shows it quite well, and it shows it with a chisel. So very important to see what at this stage you could actually crack the metal, right? So the brittleness and strain must be tempered, okay, which is drawn out of the steel before you can basically use it. Do the following steps when you're doing this. So heat the steel carefully and observe any color changes. We talked about the color change, and when you change it now, it's to a different color. We talked about, again, different colors earlier, and so at this point you're going to change it to a different color. Okay, so pay attention to the one graph below here. Stop heating when the area you are tempering reaches the necessary temperature, and then you will quench it again. Okay, those are the steps that you're gonna do. Okay, hardened steel tempered by heating to a temperature that is below the lower critical temperature, and then allowing it to cool just by air. It's really good. So if you have access to an oven, like we mentioned before, then that would be the best thing to do. This is important. Hardness decreases as the tempering time and temperature increases. Okay, important for you to know and understand this term here. Okay. Excuse me. As you see here in this table here, it shows you what the colors and the reference to the temperature in Celsius and Fahrenheit here. Okay, and it also gives you the uses for it. So if you're making cutting tools, or if you're hardening cutting tools, that would be how you would get it to a tempered color. So here it is. Again, when we do this in the shop, we tend to try to identify as you actually using the cutting or the torch to do that. Okay, the acetylene. Okay. As I mentioned before, you can use different methods like the oven, or like you see in this special note here, and they will actually help you better and help you identify those colors better. In some cases, it's not really easy to identify the colors as it changes. Again, it's not the easiest thing. So if you have a control environment, it's way better. Full annealing. Basically, you put it into a one point. Okay, we talked about this at the beginning of this chapter. Now we're going to the third part, which is annealing. You can consider a full annealing to be opposite to the hardened part. So you basically, as it converts to martensitic steel to perlite, annealing is used to make a hard workpiece soft again within keeping the properties of the hardness. So you're actually going to make it more machinable. Okay. So this is, again, something that you'll watch in that video, and you'll see how certain pieces require you to be able to machine, and not super hard and, of course, super brittle. And therefore, you need to be able to still bend it, you still shape it, you still machine it. Excuse me. Steel is full annealed by heating it above the upper critical temperature of steel. And this is what you see when the carbon content is very important here. I could give you an example when you work in a bandsaw, for instance, and you have to cut the blade and re-weld it. You must anneal it again to keep that flexibility of the blade. Okay, So you must get a flexible steel, otherwise it will just break. The process of annealing is related to a full annealing, but it's used instead of restore the ductility of the steel that has been strained or hardened in this case. In the process of annealing, you heat the steel to a temperature below the lower critical temperature point, hold it for a specific period of time, and then allow it to air cool. That would be the best thing to do. Annealing. Normalizing a steel. Then you have to, after you do this process, you have to get it to a point where you're going to get it to a normalized state, right? So stage. So steel that has been extensively worked may develop internal strains and irregular grain structures, okay, which makes the steel difficult to heat treat again. So normalizing is the process that eliminates that part. Steel is normalized by heating it above its upper critical temperature and then allowing it to cool in air. Okay, that process, the 4 steps that you saw here, I'm going to scroll back up to when we started this objective, which is right in here, is heat treating process: hardening, tempering, annealing, and normalizing. You will find more information on this on the videos. There's many videos that we have available for you, and also we have a little bit more on the process of this in handouts in the shop when we do the hardening of the cold chisel. That's another handout that tells you more about that. So this is the last part for objective 5.